Hello everyone, this is the first lecture of Trigonometry. We will study geometry in depth, but for now, for this lecture, we are confined to the what trigonometry really means and why it exists. What are the applications made that made it beautiful, and we will study from scratch. No fancy things, nothing. We will study from scratch. So the word we will understand geometry from its morphological way, that what the words really means. Before understanding any topic, it's important to know what the words literally means to, because it makes a sense about what we are going to study about and how it would be useful for us. So let's study trigonometry. Okay, just simply see that we know that try. What this means? Try means 3, and that is gone. Gone means angle. Metry means measurement. So we understand what the terms really means. It means angles. What are the angles we need to? We need to first understand what are angles. So what are angles? So when two rays, let's suppose that we have two rays, and it start from same point. Start from 0. Let's say this is A, OA, and OB. So now the simple thing, we can calculate this distance. We can calculate its length using feet, using scale. So length can be determined. What about this? What about this? So we can. What is this? Literally means. It means that I have a ray. Both are at position initially at the position both coincide each other, and then it start to rotate. Start to rotate the angle. Let's say this is A, this is B, and OB is start to rotate. Then it's form an angle, and that's the angle. So it's some angles. What angles is? So angle, so it means when two rays meets, it's form angles. Angle. or we can see that its measure how much one rays rotate. Yeah, rotate. We start with simpler definition of angles, but we need to understand the most important definition of angles, that is right angle. What is right angle? Right angle. Before starting that, we need to know a little bit of adjacent angle, because then we define right angle in soothing way, easily. So that's why we need to first understand what is adjacent angle. So the word adjacent means simply that both are adjacent, means same as same base. You can see that. So now first thing, understand what is adjacent angle and how it is defined in the Euclidean geometry. So then we have a ray simply like that, OA, and we have an angle. We have another ray starting OB, and there is another ray OC. So we can say that, let's see what's common here. Both angle AOC and angle POC, initial point is common, initial point of emergence is common, and one arm is common. So adjacent simply means sharing one such element of one of such part. So here adjacent angles, the two angles are adjacent if they have initial point and share one arm with each other, and none arms are opposite to each other, are placed opposite to each other. Yeah, I'm not confusing with the word opposite, because sometimes the word opposite means directly, let's say it means directly before that. So here I am just telling that this is the ray, this is one side, this is the other side. It simply means that the opposite side. Yeah, both are in opposite side and both are in same side. So it it is also, yeah, you can say that it can be also adjacent angle if there is a ray, there is another, there have a common ray. Yeah. So now what is right angle? Now the most important definition of this chapter is right angle triangle. So because it will understand the theory behind the angles, we don't need we haven't discussed any measurement property about angles. So we first define what is right angle. So Let's suppose there is a line L. There is a line L, and there is another line that stood upon each other such that these two, such that the adjacent angle made by each other, let's say that is alpha, that is beta, we call that thing alpha is equals to beta, then we say it's form two right angle, and that line L2 is perpendicular to L1. That's what means the right angles. It simply means it's form when a straight line stood upon another straight line, it's form equal adjacent angles, and each angles are called right angle. Each angle are called right angle. We don't need to measure what is right angle. What's the measurement of right angle? Simply understand the definition, basic definition of right angle. Now move to the next thing. We have defined angle and then right angle. So now it's time to move on to what does it mean by three angle? Yeah, we are in Euclidean space. Euclidean space, or we can say that defined space. Here we can rotate, stretch, change the position, anything we can want. So three angles. The first things we need to understand that a straight line to right angle means it's form two right angle. We deal in terms of right angles. We don't need anything to measure about what right angles actually in numerical form. We don't need that. And then the first thing, the consequences of that, the definition of right angle. Yeah, that's the consequence. So there's no need to prove that thing. Okay, just move on to the main thing is that, so here so we can say that when two rays meet, it forms an angle. So we need three angles because we have to study about three angles. So we can say that with analogously we can say that there must exist three rays to form three angles. Yeah, there can be. Yes, that's right. Yeah, that's three rays forming a triangle. That three rays forming a triangle. we can other can say that why don't we take three angles differently. Yeah, that's really good question, but we are confined to the shape here. Yeah, I think so. So that's its triangle. That's triangle. We can deal with three angles. We can deal with three angles, but I don't know how to relate those angles. That's a good point to know how to relate those angles. So here, so what's special about that forming? That's special. That's about forming a triangle. Yeah, I have here. We have to deal with actually three angles. Three angles. 1, 2, 3, 4, 5, 6. 6 sides. But here we have to deal with three sides and three angles. So we have limited our parameters. That could be a nice thing. This is why we focus on triangle actually. Yeah, that's good to know. But when we think about taking each angle separately, yeah, the first question is that how to relate those angles. And another problem is that we have extended our parameters. Means it is quite cumbersome to actually relate those things, because how much variables you can add, the system could interact visually in their own way, but in mathematical way that would be difficult to understand. Okay, just we have come to that thing now. Okay, so now we are now to start with measuring angle. I don't think so. Just start with two simple concepts about triangles. We will now compare those things. Comparison of triangle. So that's the essence of that chapter. What are the how to compare two triangles? So the first case would be two triangles are actually same to each other. Two triangles are same to each other. That is called congruence. And we simply the first we have a triangle ABC, and there is another triangle A dash, B dash, C dash. So now how to, and these two are same to each other. It means they can coincide. We can, if we place one triangle with one another, we can overlap each other perfectly. So that's AB lies on AB, and AC lies on A, and A dash C dash lies on AC, and B dash C dash lies on BC. So, and the areas are equal. So that's the congruence. So we don't need to study that things in depth. So we simply, first there is a rule called side angle side. That's the foundational rule of congruence. It can be proved using by superpositioning it. So we're not going to discuss about that. We first need to know that what really does it mean. That side angle side means there is the angle, the angles between two sides. If angles between two sides are equal to one another, let's suppose that this is equal to this, and AC is equal to A dash C dash, and this angle B dash A dash C is equal to angle BAC. We can see that triangle ABC is similar to, that's a triangle ABC is similar to triangle A dash B dash C dash. That's what is mean by this. And we can simply say that we can place A dash B dash on AB. Now these two angles are equal, so we can place, so these lines A dash C dash lies on the line AC, and this, since A dash C dash are of the C, A dash C dash is equal to AC DC, so this coincide with each other, and simply B and C are coincide with B dash C dash, so it means BC is BC, B dash C dash also, जो B dash C dash, the line also coincide with line BC. That's a similar thing. We can, now we have another property called SSS, and then AAS, ASA, these all are, and RHS. Those are the part of the Euclidean geometry. So we are just confined with what the congruence literally mean. Don't need to dwell on that things. So now there is another thing, is similarity. So that's literally that. This is more about shadow and reflections. Forming shadow. Now we have a triangle. We have a triangle. So now we have a triangle. I don't know. So now suppose I have a light, I have a torch, something like that. Torch, a source of light. And there is a triangle. Yes, I am just, for simplicity, I am drawing these things because I don't know. Yeah, that's okay. Yes, that is parallel. He just no, that's completed. That is the source of light. Yeah, that's the source of light. A, B, C is a triangle, and A dash, B dash, C dash is the shadow of that triangle. So now the another thing to notice that the light coming from source is perpendicular to the surface. So any light coming from, yeah, just simply it means that there is a light. This is the light, all directions, and here this is our triangle, and here is the projection. Here is the projection that we want. So that forms sine right angle. That is torch or any source of light. So here what similarity really means, we are just projecting thing. We are just projecting things in light, and then there's this torch that is perpendicular. Perpendicular, we can also say that the rays coming. Rays, so there is a ray that is perpendicular there, that is perpendicular to the surface or triangle and perpendicular to the light source. Yeah, that's the better way to say that, because any ray can be perpendicular to any surface here. So that's the better way to understand things, that there is one ray. There should be one ray that is perpendicular to the surface of the torch, and that is perpendicular and also perpendicular to the triangle surface. And there we can say their projected things. So that's the projection. So what the projection really does, it just increases size. It does nothing. It doesn't change any angles. It doesn't no angle change. So angles are preserved. There is one constraint: angled are preserved. So simply it means the angles are preserved. So or we can say that if I have a triangle, if I have two triangles, so it means that's our property to determine the two similar triangles. Let's say ABC is a triangle and there is another triangle A dash B dash C dash. So these two are similar. These two are similar if the angles are equal. Yeah, if angles are equals. We have another property same as SAS. We can prove that things. There is another we can also prove SSS property here. So that's enough for understanding trig. Yeah. So now move to the another thing. We have studied angles. We have studied angles, right angle triangles, and then triangles, and then comparison of triangles. And now we start with simple basic question that let's suppose we have a stick. We have a stick of length L. Of length L, and there is a pole. The pole which height is measured. Height is measured, and we need to find. So now let's try to think about that. How to measure height of the pole? Of course, it is perpendicular to the surface. Yeah, there is height of the pole, and there is a stick, and we need to find how to measure. We have to understand two things about comparison. About comparison of triangles. So we have let's suppose height is h, and this is given. This is given, and this height, this distance could be found. This distance could be found, and there will be a time. There will be a time in the day when the rays coming from any source, let's say sunlight, is coming. That's coming. That overlap that shadow of L, shadow of our stick will overlap with shadow of the high shadow of the pole. Overlap doesn't mean that they have the same length. It means that the length L end point overlapped with the end point of H. Now for simplicity we can say that is A, B, C. A dash, B dash. So now simply this angle is same in both two triangles A, B, C, and A dash, B dash, C. Let's suppose that we don't need the such things. Let's suppose that is alpha. We can now these two triangles in triangle A, B, C, and triangle A dash, B dash, C, angle A dash B dash C is equal to angle ABC, and ACB, angle A dash CB dash is equal to angle ACB. So we can say that triangle ABC is similar to triangle A dash B dash C. So it means two triangles are similar, so then they are the ratios. It means both triangles are expanded by some constant or some ratios. So we can say, we can now conclude that AB by A dash B dash is equals to BC by B dash C dash. Here we need to find this A dash B dash. It means that is AB into B dash C dash by BC. We can calculate AB is given. We can calculate B dash C, and we can calculate BC. So we can find that height of the triangle, height of the pole. Yeah, that's what we have talked about. We have think the one thing. So that's the end of our lecture. The next lecture we will study next part of that thing.